Alright, welcome everybody. Let's do this. So, lesson 15, part 1. What is game plan? Students bridge the connection between the effect of the moduli of the product of two complex numbers and their arguments. So, we'll come back to what this learning intention means. But what I'd like you to do is, for the opening exercise, if this is my z, this is my w, I want you to calculate zw and then graph z, w, and zw. Okay? So if you want to do it with me here, if I have my complex plane, right? Where is 3 plus I? 3 plus I has to be over here. 1, 2, 3, and I. So bam, that is my z. Where is my w? It will be 1 plus 2i. So 1 plus 2i. This w should be over here. And what we need to do is we need to calculate what is z times w and then graph it here. So my z is 3 plus I, and what's my w? It's 1 plus 2i. So let's multiply. 3 times 1 is 3. 3 times 2i is 6i. I times 1 is I times 2i is positive 2i squared. So this becomes 3 plus 7i, and this is minus 2 because I squared is equal to negative 1. And this becomes 1 plus 7i, right? So now that we have 1 plus 7i, where is it? It's 1, and then 3, 4, 5, 6, 7. So this should be our zw should be over here. And the question that we're going to have today is, imagine if we have these 3 points, right? Like if I have z, okay, it's over here, and then I have w, it's over here, and then if I have zw and it's over here, is there a connection between the modulus of z, the modulus of w, and the modulus of zw? Is there some sort of connection that bridges these things? Like, is the distance from here to here and the distance from here to here, is there some sort of relationship with the distance from here to here? Is there a relationship with the argument of z? Like, is there a relationship between this angle, and the angle that's, the zw that got multiplied together? Is there some sort of relationship that's happening with the argument and the moduli? Okay, so that's what we want to explore today. And the way we can make this connection is if we can convert zw and zw into polar form. Okay, so that's what I want you to do. I want you to take z, let's say it's 3 plus I. Let's put it into polar form. And how does polar form look like? It looks like some r times cosine theta plus I sine theta, right? We want this to look like this. We want our w, what's our w? It's 1 plus 2i. Okay, let's make this look like this from the previous lesson, right? And we will need the calculator for this because our angles won't look like the nice triangles that we have. And let's also do it for 1 plus 7i. Okay? So try and do it by yourself. And if you feel lost, remember this is, we did this in lesson 13, part 4. So if you feel like, oh, I need to review how to do this, just watch that lesson. But if you want to see how it's done with me, let's do it together. So if I have 3 plus I, what's the first thing I want to do? I want to calculate r. So what is r? R is equal to the modulus of z. And this is my z, right? So it is 3 squared plus 1 squared, right? Because here, remember, the modulus of z is equal to a squared plus b, the square root of a squared plus b squared. So this just becomes a square root of 10. Okay, so I know that r is the square root of 10. So we got that part. But remember, what we want to calculate this theta. And what does that represent? Remember, that represents the rotation, right? When we graph this here, this z, I want to know how much it rotates, okay? I want to calculate that rotation. Here, if I make my triangle, if this is, remember, if it's 3 plus I have to go 1, 2, 3. So I know the triangle I'm making has this distance of 3. And I'm going up 1. So I know that the distance of my triangle is 1 going up. And then what's the length from here to here? But remember, this is the modulus, right? This is the modulus. We have that. That's square root of 10. And if you want to check it using a squared plus b squared plus is equal to c squared, right? It'll work, because if I have 3 squared plus 1 squared, it is equal to they're equal to each other if you do the math. So then here, our question right now is, what is this angle here, right? And here, we cannot use our very famous triangles. Let me give it a second right here. These triangles are we can't use them. So to find this, we want to use what was the skill we learned? It was where did it go? This one. We wanted to use the inverse trig functions to be able to calculate this. So what I could do is, I can choose any one of them. I could choose sine, cosine, or tangent. Usually, I like to use tangent because it's just very straightforward. It's just this one and this one. It's opposite over adjacent. So what is the tangent, remember, of theta is equal to opposite over adjacent. So this is 1 over 3. So then we need to use the inverse of tangent, so of 1 over 3. And this will calculate that theta that we're looking for. We're going to calculate that angle using this notation. So here, let's get into our calculator. Let me zoom in so you guys could see it nice and clear. My mode, I'm in degree, so that's a good thing. Hit enter. Second quit. Let's get out of here. Okay. So inverse tangent of 1 divided by 3 is 18.43. So I know that this is 18.43 degrees. This 18.43 means that my z, that this rotation was 18.4 degrees. And now that we have this, that's our theta. That's the theta I want to plug into here. So then what will 3 plus I look like? It should just only be, and I'll put it over here, it should be square root of 10 times cosine 18.4 degrees, 0.43 degrees, plus I sine of 18.43 degrees. Okay? And if you want, you could use the calculator to check it. And you should get back the original of 3 plus I. Okay? What I want you to do is try and do the rest by yourself. Do this one by yourself, do this one by yourself, and then come back to the video. Okay? I'm going to put up the solutions in another video, but what I want you to do is, if you found this and you found this, and you want to continue forward, I also want you to do this. Okay? Let z equal this, let w equal this, calculate zw, graph zw and zw, and I want you to do the same thing. Convert these three into a polar form. So the same thing that we did over here, right, for this problem of calculating the polar form for these three, I want you to do it for these three. And do the same thing for this one over here as well. And then we're going to see some sort of connection. We're going to come back and we're going to see the connection of what happens when these are in rectangular form. What do they mean in polar form? And is there a connection that we can make that will show this connection of the moduli and the argument? What does it mean in polar form and their connections, okay? That will happen in the next video.